Alright, so this video we are going to be looking at simplifying trig identities. So if you, well, from the last video here from 6.1, you should know the basic trig identities, and what we're going to be doing is using those to try and simplify other trig expressions down. So I'm going to start you out with looking at this one where we have tangent x cosine x. Now, it doesn't look all that complex right now, but we can simplify it down to a single trig expression, okay? And how we can do this here is I can take tangent and I can rewrite tangent, because tangent is the same thing as sine over cosine. And now if I multiply it by cosine x, because I'm dealing with multiplication here, the cosines cancel out, and I am left with the sine of x. So now I'm going to show you on the calculator. Okay, if we look at the graph real quick, so I put in tangent x cosine x, and I just want you to see that when I hit graph, now just on my calculator, I am in radian mode. I did go just from 0 to 2 pi. My scale is by pi over 4, and then my x and y minimum goes to negative 1.5. So when you graph it out, notice right there that that is the exact same thing as our sine curve. So tangent x times cosine x is equivalent to sine of x. All right, let's take a look at this one. Secant x plus 1 times secant x minus 1. When you look at this here, trying to simplify it, we're trying to simplify it down to a single trig expression. Sine, cosine, tangent, cosecant, secant, cotangent, just a single one of those. And I see sets of parentheses. Well, that should be an indication to you that you want to go ahead and use the FOIL process. So we're going to take secant times secant x. Secant times negative 1, 1 times secant, and 1 times negative 1. And when we do that, we get secant squared x minus a secant x plus a secant x minus 1. And our negative secant x and secant x are going to cancel each other out. And now I'm left with secant squared x minus 1. Now, if I look at this, this can get broken down even further, because when I look at some more identities, and more specifically our Pythagorean identities, one of those Pythagorean identities can be rewritten so that secant squared x minus 1. And the one that I'm looking at here is 1 plus tangent squared theta equals secant squared theta. Remember that you can always rewrite these. And so this problem here, if I were to subtract 1 from both sides, I would get tangent squared theta equals secant squared theta minus 1. And so now I can take this entire statement right here, and that is equivalent to tangent squared x. And so we've simplified that down. Now, just like we can do foiling out things, sometimes by reversing that process and by factoring something out, that might be a way to help us. So we're going to try and be using all the techniques that we've learned from Algebra 1 to Algebra 2, and even what we've talked about here in pre-calc, to try and make these a little bit more, break them down and make them simpler to work with. So when I look here, I've got sine x cubed plus sine x cosine squared x. Notice that you've got a sine x in both of these. So if I were to take out a single sine x, I am left with sine squared x plus cosine squared x. And by taking that sine x out of there, a familiar identity right here of sine squared x plus cosine squared x, that equals 1. And so now I have sine x times 1, which we know anything times 1 is itself. So we get this to simplify to sine x. All right, so what I want you to try and do is see if you can take this one here and see if you can simplify any of it on your own. All right, so hopefully on this one you went ahead and you FOILed out your numerator. Your secant x's are going to cancel out. You're left with the secant squared x minus 1, which now, using that 1 plus tangent squared x, we can rewrite this, and we can say that tangent squared x is divided by sine squared x. And this is where I'm guessing many of you might have got a little bit caught up in trying to think of where do you go from here. One thing that you can do here is what I a lot of times will suggest, it doesn't work all the time, is trying to always rewrite things in terms of sine and cosine. So I'm going to take this tangent squared x and I'm going to rewrite that. And because it's being squared, we would have to take sine squared x divided by cosine squared x. And that will all be divided by sine squared x. So rewriting your tangent squared of x. You have to do sine and cosine. Now you are dividing by fractions. And when we divide by fractions, we multiply by the reciprocal. So we're going to take sine squared x over cosine squared x, and we are going to multiply it by the reciprocal here. So 1 over sine squared x. And by doing that, now our sine squared x's are going to cancel out. I have 1 over cosine squared x, and that can be rewritten as the reciprocal identity of secant squared x. All right, here's another one, kind of similar to the last one. Try and see if you can do this one all on your own. All right, so we should have ended up with the cosecant squared x. Foiling out the numerator, we get cosecant squared x minus 1. We can rewrite that as the cotangent squared of x. Cotangent would be cosine over sine. Divide that by cosine. And do a little canceling, and you got it. Now, the next couple that I want to get into is working with some fractions. So just a reminder to you of how do you simplify fractions. We know that when you have a common denominator, we just add the numerators together. So here we have an x in our denominator, so 1x plus 1x would be a 2x. 2 plus a negative 7 would be negative 5, and that is how you simplify with a common denominator. So when you're working with functions like this here, you got to keep those things in mind. Now here you have two fractions, common denominator, you're adding them together. So we've got tangent x in our denominator. Then I look on the top, I'm taking cosine squared x plus sine squared x, and this is going to be one of those identities that you want to have memorized. And cosine squared plus sine squared is always going to give us 1. And so now I'm going to have 1 divided by tangent x, and now we can use our reciprocal identity, and so we are left with the cotangent of x as far as what that simplifies to. Now, what about if you do not have common denominators? So here I've got x, here I've got x minus 1. You have to find your common denominator, and that's that least common multiple. And so here I've got a factor of x, here I have a factor of x plus 1. I would need to multiply our numerator and denominator by that factor of x. Here I'd have to multiply by the factor of x plus 1 in order for us to have this common denominator now. So x times x plus 1. And now you would be able to go ahead and simplify this out. Just be careful with subtraction. Here, if I were to FOIL, I would get x squared plus 3x plus 2. And if I multiplied out the other part here, I'd get x squared minus 3x. And when doing subtraction, just make sure that you're subtracting everything on that second set here. So x squared minus x squared, those would cancel out. But a 3x minus a negative 3x, now you're adding that. So that would give us 6x plus 2 all over x squared plus x. So when you're working with the trigonometric functions here, treat these like they are the factors. And so I'm going to have to multiply here by a factor of cosine x. And I'm going to have to do that to the numerator and denominator. Here I'm going to have to multiply by that factor of 1 minus sine x. And so now you have your common denominator of cosine x times 1 minus sine x. And now when I look up on top, I've got cosine squared x minus, and I'm going to subtract a sine x minus a sine squared x. As I subtract both of these parts here, we have cosine squared x minus sine x plus a sine squared x all over cosine x times 1 minus sine x. Now, I don't like to FOIL things out until the very last and final part because you might have some things that do cancel. Here I have a cosine squared x and a sine squared x that are being added together. So that right there is giving us a 1, and I have 1 minus sine x divided by cosine x times 1 minus sine x. Well, notice your numerator and denominator both have that 1 minus sine x. That's going to cancel out. So I have 1 over cosine x, and that gives us the secant of x. So now I'm going to be kind of letting you go with all of this, okay? You guys are going to have an assignment that is going to be challenging. I'm going to be giving you 2 days to work on this video as well as work on the assignments. I'm guessing there's going to be questions that are out there. Take your time with it. You might want to take a step away from the problem for a little bit and then come back to it. You might have to start over on problems as well. But these are just some suggestions that you can do as you're working forward with it. And just take your time, don't rush through it, and we'll be spending some time doing this over the next couple days.